Alright guys, so I thought I would do an example of how the proof of the Pythagorean theorem works with a right angle triangle that we have numbers for. So here's our right angle triangle here. So it has legs of length 12 and of length 5, and the hypotenuse is of length 13. And you can check that is indeed a right angle triangle by using the Pythagorean theorem, or you can just measure the angles. But let's show you how this works. So we want to show that the area, or we want to show that a squared plus b squared equals c squared. And we know we can check that 5 squared plus 12 squared equals 13 squared, but let's pretend we didn't know that. We're just going to use the idea of the proof of the Pythagorean theorem that we did in class, but with actual numbers, just so we can see it work, see it in action. So remember, we said, so this angle here on the second triangle, this angle here, is the same as y, since it's the same triangle. So let's make that y. And we know we can check that x plus y, so the measures of those angles, is 90 degrees. So the measure of the angle in here, this angle here, we'll call it z, has to be 90 degrees as well, since this here is a line, and the line is being split into 3 different angles. So these angles have to add up to 180 degrees. We already have 90 degrees from x and y, so it's just z that's left over. So z has to be 90 degrees. And just as an aside, you can calculate, if you know a little bit about trigonometry, you can calculate that if you do have a triangle with these side lengths, then the angle x here, the smaller angle, is 22.6 degrees, and the bigger angle y is 67.4 degrees. So we know that angle z is a right angle, so let's mark that in. So here is our right angle, and we know we can apply the same logic to all the other 4 corners. So we have that the area of the small square, and here we know it's a square now, since every side is of length 13, since you put 4 of these triangles together. Every side is of length 13, and every angle is equal. They're all 90 degrees. So we know the area of the small square is just going to be 13 squared. The area of the big square, well, the big square has side length of 17. So we know that the area of the big square equals the area of the small square plus the area, well, we included the small square, but we still have each of these 4 triangles. So it's going to be the area of our triangles, and there's 4 of them, so we'll multiply the area of one of the triangles by 4. So, well, we know our side lengths are 5 and 12, so the area of the big square, let me write that formula again. So area of the big square equals the area of the small square plus 4 areas of our triangles. And you can go back in the video to refresh yourself about what the side lengths are. But the area of the big square is going to be the side length of the big square squared. So the side length is 12 plus 5, since each side is made up of each leg of the right angle triangle. So we're going to get 12 plus 5 squared equals, well, the area of the small squared, that had side length 13 squared, and then 4 times the area of each triangle. Triangles had base of 12 or height of 5, or the other way around, so it's going to be 4 times 5 times 12 divided by 2. So now, well, we can just simplify each side. So this is going to be 17 squared. So that equals 13 squared plus, well, this is going to be 4. We can cancel out one of the 2's out of the 4 with this 2. And we're left with 2 times 5 times 12, which is 120. So 17 squared is 289. You can check that if you like. And 13 squared is 169 plus 120. And look, both sides equal. So we're good to go. Now notice, we had numbers here, so we could simplify the numbers as we went. In class, when we were doing it in general with any side lengths, A, B, and C, well, you can't add A and B and just square it. You have to use the distributive property to multiply that out, and you're going to get 4 different terms. So that's kind of the difference there, but hopefully this example with numbers lets you see what's happening.